Hello, students, and welcome to the review for Unit 2 of Algebra 1A. This unit is called Linear Equations, and this is the basis of algebra. So let's get started. The objectives we're going to look at are reviewing how to write equations, how to solve equations, how to solve literal equations, that means kind of formulas, and how to solve percent problems. The vocabulary that you need to be familiar with is identity. That's an equation that's true for all values of the variable. A literal equation, like I said, that's an equation containing more than one variable. A multiplicative inverse, that is the reciprocal of a number. So if you have 1/3, the multiplicative inverse would be 3. Any two numbers that you multiply together to make 1. And the solution, which is the set of values or just maybe one value for the variable that would make the algebraic equation true. So you learned about these properties, identities and inverses. I talked about the multiplicative identity already. Multiplying or dividing by 1 results in the same number. The additive identity is 0. That's if you add or subtract 0 from something, it remains the same. The multiplicative inverse, like I said, is the reciprocal of a fraction, or a fraction if you have a whole number that has that number over 1. Two things that you multiply together to make 1. But there's also an additive inverse, and that is the opposite or negative of a positive number, positive of a negative, any two terms that add together to make 0. Solving equations follows a specific step. The idea is that you're going to do the same thing to one side of an equation that you do to the other side. And the idea is to take steps so that you isolate one variable, usually x, to determine what the value of that variable is. So when you have to add something to both sides of an equation, it's called the addition property of equality. That would happen if you had something where x is being subtracted by a number. So if a number is being subtracted from x, in order to undo that subtraction, you will add. That's the opposite operation. You just have to remember to do it to both sides of the equation. So here, x minus 7 equals 14 can be solved by adding 7 to both sides. That will cancel out the negative 7 on the left and make 21 on the right. Same thing is true for the subtraction property of equality. If you see that something's being added to x, you choose the opposite operation, which is subtracting that number. And when you do so, it cancels out on the left. And also on the right, the number adjusts in the same way. So here, x equals 7. The multiplication property of equality is the same thing, but it occurs when x is being divided by a number. You have to do the opposite. The opposite of division is multiplication. So here, x over 7 means x divided by 7. So you'll multiply both sides by 7. The 7's cancel out to 1, leaving just x, and the value on the right becomes greater by a factor of 7. The same thing is true for division. If you see that x is being multiplied by a number, use the opposite operation, which is division by that same number. Those values will cancel out on the left, and also the number on the right will adjust in the same way. They're called properties of equality because you have to do them to both sides to keep the equation equal. Sometimes the equations are not that simple. If at least two things are being done to x, then it's called a multi-step equation, and it takes more than one step to finish. I'm going to go over some two-step equations. Here you see an example where 3x plus 7 equals 46. Not only is x being multiplied by 3, but it's also having 7 added. Now, it's important to know that you have to undo addition and subtraction before you undo multiplication and division. This is the opposite of the order of operations that you used when you were simplifying equations. Because we're undoing things, we undo them in the opposite order. So here I'm going to subtract 7 first, and remembering to do it to both sides, it simplifies to 3x equals 39. Finally, I'll undo the multiplication by dividing both sides by 3 to get x equals 13. Here's another example. 3x over 6 equals 1, plus 1 equals 7. I'll undo the addition and subtraction first by subtracting 1. That gives me 3x over 6 equals 6. Now at this point, you could do the next step in one step, but I usually split it up into two because it decreases the mistakes that you can make. So I see that x is being divided by 6 and also multiplied by 3. So I'm going to undo the division by multiplying both sides by 6. Those 6's will cancel out and give me 3x equals 36. Then I'll go back and divide both sides by 3 to get x equals 12. The distributive property is one that's really important in algebra and one that you often see. It involves some number on the outside of a set of parentheses that must be multiplied by both of those terms. The reason why it's called the distributive property is because you distribute that number on the outside to both of the terms on the inside, and it could be many terms on the inside. You have to remember to use the multiplication of that number by each term. So if you started out with this problem, 2 times the quantity 2x, or 5 times the quantity 2x minus 1 equals 6, you would first multiply 5 by 2x, then put the subtraction sign, then go back and multiply the 5 times 1. 5 times 2x is 10x, negative 5 times 1 is negative 5, so your simplified expression or equation in this case is 10x minus 5 equals 6. Now, once that distributive property is finished, you can see that you're left with a nice little two-step equation that can be solved in the same way I just described. 5 is being subtracted, so you'll add it first, remembering to do it to both sides, and get 10x equals 11. Finally, you will divide 10 from each side because it's being multiplied. 10x divided by 10 leaves x alone, and 11 divided by 10 is 1.1. Sometimes you start out with variables on both sides of an equation. So your first step is always to move the variables to one side of the equation. Here's an example. 5 minus 3x equals 2x plus 9. The first thing I'm going to do is to add 3x to both sides to combine the x terms. Now, would it be okay to subtract 2x from both sides? Yes. Either way, you're taking, if it's being subtracted, you'll add it. If it's being added, you can subtract it. I just know from experience, I like adding more than I like subtracting. So if I see that one variable term is being subtracted, I always add that to the other side. So here, if I add 3x to both sides of this equation, I end up with just 5 remaining because negative 3x plus 3x is 0. And then on the other side, I added the 3x, and combining those like terms gives me 5x plus 9. And then you can recognize that this is a two-step equation that you know how to solve. Undoing the addition and subtraction first, you'll subtract the 9. 5 minus 9 is negative 4, and the 5x remains on the right. Finally, divide both sides by 5, gives you negative 4 over 5 equals x. Literal equations means that it has more than one variable. So here's an example where r equals x times a plus b. We have 4 different variables here, and it currently is solved for r because r is the variable that's isolated on one side. But we can change this around. This is like a formula that you might see. It's easier to do the computation if you solve it first for the variable that you were looking for in your problem. So let's say that we wanted to solve for x instead. That means that we're trying to get x alone, just like in the equations we've been looking at. And my first step, because x is being multiplied by the quantity a plus b, is to divide both sides by the quantity a plus b. So it would look like this. R divided by a plus b equals x times a plus b divided by a plus b. Once the term on the right is divided by the same term that's on top, they cancel to 1 and leaves you with just x. Once x is isolated, you can say this problem is solved for x. Now, let's say that you want to solve for a. That's a little bit more complex. To get a out of those parentheses, because we don't have any values to evaluate, we need to first use the distributive property. X times a plus b would be ax plus bx. Now we can take away everything that is not a, and remembering to undo addition and subtraction first, I'm going to subtract the bx from both sides. So that becomes r minus bx, and the bx minus bx turns to 0, leaving just r minus bx equals ax. Now, remembering that I want a by itself, the only thing being done to it is division or multiplication by x, so I'll divide both sides by x. Now, when you have two terms on one side that have to be divided by 1, you just put them inside some parentheses and then put the slash sign x, or you could put it right underneath as a fraction, or you could put a division sign. And ax divided by x is going to leave me with my desired result. The a is isolated. To solve for b, I would use the exact same process, except that I would subtract the ax first and then divide by x. Now, I know that this is fairly complex. You'll have several problems that require you to do this. It's very powerful, though, when you finally figure out, hey, I can switch this around and solve for any particular variable. So go ahead and give it a try. If you need to stop the video and try a couple, or if you need additional help, please let me know. When it comes to writing equations from word problems, you're looking for some key words that you can translate from English into algebra. You're probably familiar with some of these. Sum or total would probably mean to add. Difference or less than means to subtract. Product or times means you better multiply. And then the quotient or into or groups means to divide. Usually, when the problem is set up, there is a verb in the sentence you're translating, such as is, are, results in, for instance, that indicates where you're going to put the equal sign. And here's an example. 6 times a certain number added to 8 results in 32. The verb here is results in, so you can see I put that right before my number 32. A certain number is usually where you put your variable, so 6 times a certain number would look like 6 times x. Added to 8, that one's pretty obvious. You're going to put a plus and an 8, and then equals 32. Now, be careful to put quantities into parentheses when you translate. So there are some keywords, what I call total words, like sum, difference, product, or quotient, is usually followed by some numbers and the word and. That's where you would put that operation sign. However, you might see something that talks about the quantity of or the sum of, which means you're going to put those parts into parentheses. So here's an example. 10 times the sum, there's one of those total words, of a number and 14, there's that word and, is equal to, there's your verb, 9 times the number. Notice it's not a different number, it's the same number. This is what it translates to. 10 times means it's going to be on the outside. A sum means it's going to have to be included in parentheses, a number and 14, x plus 14. Remember, the plus sign goes where the word and is equal to, is pretty easy translation, and then 9 times a number is 9x. Because this sentence said the sum, you must include the addition portion in parentheses. I introduced you to the process called VEST. VEST is just an acronym for identify your variable, write the equation, solve the equation, and test it out. When your problem asks for you to show all steps, you must show all steps to get full credit. But this is just a good habit to get into because algebra is complex and sometimes you can make an error. That testing step is often overlooked, but it's very important. And sometimes identifying the variable is actually the hardest part of an equation, so that part is super important to do first. Here's an example of a question that would benefit from the use of VEST. Peggy had 3 times as many quarters as nickels. She had $1.60 in all. How many nickels and how many quarters did she have? Okay, so we're starting with step V, and I'm just going to pick a variable. It doesn't have to be n, but here I picked n because it starts nickels. So I set up n equals the number of nickels, and then looking at the relationship, it says she has 3 times as many quarters. That means I've got 3 times the number of nickels is going to equal the number of quarters. Now, sometimes students send me something that says n equals the number of nickels, and they're done with step V. But remember that using that same variable to set up a representation of the other information in the problem is equally as important. Now, when we're working with money, there's always a common pattern. You have to put the value of each coin times the number of coins in order to figure out the total value of that part of the money. So here I've got 0.05, which is 5 cents, times n, the number of nickels, plus 0.25, which is the value of 1 quarter, times 3n, which is the number of quarters, equals $1.60 in all. Now, when dealing with money, you want to keep your form consistent. If you don't want to use 0.05 and you just want to put 5 instead, that's fine if you're talking about cents. But remember, $1.60 would have to be written as 160 cents. Solving the equation, first you would do the multiplication to get rid of the parentheses. And the only thing we had to do here is multiply 0.25 times 3 to get 0.75. Everything else is pretty straightforward. Then these are like terms, so they can be combined. 0.05 plus 0.75 is 0.8. So 0.8n equals $1.60. Now it's just a one-step equation. To isolate the n, I have to divide both sides by 0.8, and I end up with n equals 2. Now, that's not the end of the problem, not even the end of the solution. You must also tell how many quarters, so figure out 3 times n equals 6 for the number of quarters. Now, to test it out, I just take my equation, put my values in that I found out. 0.05 times 2 nickels is 0.1 or 10 cents. 0.25 times 6 is 1.5 or $1.50, and they do indeed add to 1.60 or $1.60. Now, representing age is always problematic. A lot of times you're given somebody's age, you tell whether it's older or younger than somebody, you tell whether they're going to be this age in so many years or this many years ago. So here are some clues on how you can do this. Ralph is 3 times as old as Sarah. In 6 years, Ralph will be only twice as old as Sarah. Will be then. Find Ralph's age now. Okay, the reason I put this in red is because we want to solve for Ralph's age, and I've represented his age as R, but everything else is in terms of Sarah, so I'm representing her age as S. So in my variable setup, I've got S equals Sarah's current age, and I'm representing Ralph's current age as 3S because he is 3 times as old as Sarah. So he's whatever Sarah's age is now, 3 times that is his age. So if she's 2, he is going to be 6. If she's 20, he's going to be 60. Okay, now in 6 years, Sarah will be S plus 6. However old she is now, she's going to be 6 years older. So I'm just going to add 6 to her age. And Ralph will be 3S plus 6. 3 times her age plus 6 more. So here's my equation. 3S plus 6, that means Ralph's age is twice, meaning 2 times, Sarah's age then, which is S plus 6. Notice I put that in parentheses because he's twice her whole age, not just her age now. Simplifying that, I have 3S plus 6 on the left. Using the distributive property, I get 2S plus 12. And now I can subtract 2S from each side to get my variables onto one side. When I do so, I end up with S plus 6 equals 12. And now this is a simple one-step equation. S is being added to, so I'll subtract 6 from each side. And I get that S equals 6. What I'm looking for, however, is Ralph's age. So I go ahead and do the next step, 3S equals 18. So Sarah is 6 and Ralph is 18. To check it out, I put it back into my equation. 3 times 6 plus 6 equals 2 times 6 plus 6. And 18 plus 6 equals 2 times 12, and 24 equals 24. So it checks out to be true. Now, another thing you're often asked to represent are consecutive numbers, or consecutive odd numbers, or consecutive even numbers. So remember, if your first number, the lowest one, is represented by a variable, say x, then the three consecutive numbers would be x, the first one, x plus 1 for the second one, and x plus 2. So if your first number is 4, the next one would be 5, the next one would be 6. So if a number is x, three consecutive odd or even numbers would be x, x plus 2, and x plus 4. So if you started with 2, x plus 2 would be 4, x plus 4 would be 6. So you're counting up by 2s. Here's a problem from your assignment. Find two consecutive integers whose sum is 67. Integers shouldn't scare you. They're just whole numbers, so we know that we're going to be adding 1 to get to the next one. It doesn't matter whether it's positive or negative. So I'm identifying my variables. X is going to be my first number, and because they're two consecutive numbers, the next one will be represented by x plus 1. Then I add them together because it says the sum is 67. X, the first number, plus x plus 1, the second number, equals 67. Now you might wonder, should I keep that x plus 1 in parentheses because that's just one number? You could, but because they're being added, it's not necessary. Combining like terms, x plus x is 2x, plus 1 equals 67. Now you have a simple two-step equation. Subtracting 1 from both sides gives you 2x equals 66. Then your last step is to divide both sides by 2 and to get x equals 33. The next consecutive number, remember you want to keep that next step in there because it asks for both the numbers. X plus 1 is 34. Now I can test it out by putting these values back into my original equation. 33 plus 33 plus 1 equals 67. And when I simplify it, it really does. Distance and speed problems often use this formula, d equals rt, or distance equals rate times time. Let's see how you could use this formula in this problem. Tom took a trip of 1,020 miles. He traveled by train at 55 miles per hour and the same number of hours by plane at 285 miles per hour. How many hours did the trip take? Okay. Well, what I'm trying to find out is the hours, so I'm going to use that as my variable, and I've called it h simply to help me remember I'm figuring out hours spent traveling in all. Here's my equation. 55h, that's 55, the rate, times the hours that he traveled at that rate, and this is the train time, plus, because he took two different sections, 285, that's the rate of the plane, times the same number of hours, they told me it was the same number of hours, is going to equal a total of 1,020 miles. Now, distance is in miles. That's why by multiplying rate times time, I'm going to end up with distance. Okay, there's my equation. I'm going to combine these like terms. 55 plus 285 makes 340 total. H equals 1,020. And this is a simple one-step equation. I just have to do one operation, and that's to divide both sides by 340. So H equals 3. So is the answer 3? That's the hours spent traveling, or 6 hours for the whole trip. So filling in the 3 for my H's, I get 55 times 3 plus 285 times 3 equals 1,020. 165 plus 855 does equal 1020. Now, look back at your question or your problem at every time you come up with your answer. Your work may be great. You may come up with H equals 3 and think that that's the answer, but look at the question asked. How many hours did the trip take? They're talking about both legs of this trip, the one by train and the one by plane. So 6 would be your answer to this question if that were all you were asked. Okay, decimals, fractions, and percents were an important part of this because not every problem comes out to be even whole numbers or even decimals. but they're all ways to show part of a whole, and we can easily work with them using the same techniques we've been using with whole numbers. Sometimes you have to change percents to fractions or fractions to percents, and that's pretty easy to do if you think of percents as any number over 100. Percent literally means out of 100, so 45% is the same as 45 divided by 100. That's in its fraction form. Now, that can be written as a decimal because remember, if you divide something by 100, you just move the decimal place 2 spaces to the left. Or if you read it, 45% equals 0.45. If you remember how you learned to read decimals, this is 45 hundredths because it ends in the hundredths place. 45 hundredths is the same as 45 100ths, so these are all equivalent to each other. If you want to change a fraction to a decimal, you can divide it out with your calculator. You can remember that dividing by 100 is pretty easy. Just move the decimal place over if the denominator is a power of 10. But any fraction can be converted to a fraction by simply dividing the numerator by the denominator, and that's most easily done with your calculator. Okay, there's one special type of problem that throws people off, and that is the percent increase or decrease and the percent error. When you're asked to find the percent increase or decrease, first, you're always given 2 numbers. Find the difference between the first number and the second number by simply subtracting them. Then divide that difference by the initial percent. So here's an example. You increased your test score from 60% to 80%. What is the approximate percent increase of your test score? Well, I'm going to take my 2 numbers and subtract them. The difference between them is 20, so I've gone up 20%. Then I'm going to put that difference over the initial amount, which was 60%. And here I've reduced it down to 1/3. So 1/3 is actually 0.3 repeating, or about 33.3%. So I've increased my scores by 33.3%. Now, the greatest possible error is half of whatever unit you have used. So if your measurement is 0.6 grams, the unit is tenths of a gram, and the half of that is 5/100ths of a gram. So 0.05 plus 0.05 is 0.1. So I take half of the units. Remember, I'm not taking half of the 6, I'm taking half of the units. This one is written in tenths. So my unit is tenths, and half of that is 5/100ths. Now, you can use that greatest possible error when you're finding the percent error. First, you find the greatest possible error. Then you divide the greatest possible error by the actual measurement. So in this case, I'm going to take my 0.05 and divide it by 0.6. Then you change the decimal to a percent by multiplying by 100. And here's an example. A scientist measures a substance to be 0.6 grams. Calculate the percent of error in the measurement. Show all your work for full credit. The greatest possible error we've already discussed. Half of 1/10 is 5/100ths. Putting that over my actual measurement, 0.6, results in 0.083 repeating. And if I multiply that decimal by 100, I end up with 8.3%. Finally, you were given quite a few interest problems, and these will continue to show up in your course. So this formula is very important. I equals PRT. I is the interest, P is the principal, which is what you initially invested or what you initially loaned. Rate is represented by R, and time is represented by T. So here's a problem where you would use this formula. $5,000 is invested at 3% interest. How much money must be invested at 5% interest so that the total interest from the 2 investments is $275 after 1 year? Okay, so we're looking for some key things. We're looking for the interest, which is what we're looking for, so we don't have that. Well, actually, we do have that. We're looking for a goal of $275 in interest. Then we're looking for principal, and we know that part of the principal is this $5,000, but we have another investment with an unknown principal. So I've represented that with my variable P. Then we have a rate for the first amount. 3% is represented by 300ths. The time is 1 year. The second investment will be invested at 5% interest, so that's represented by 0.05 or 500ths in the same time period. The interest that I want to earn is going to be a combination of these two accounts, so I've added them together. Simplifying these, 5,000 times 0.03 times 1 is 150. 0.05 times 1 is 0.05. So now it becomes a two-step equation. Subtracting 150 from both sides gives me 125 equals 0.05p. Dividing both sides by 0.05 gives me 2,500 for p. That means that $2,500 must be invested at 5% interest in order to get that amount of interest. Now, mixture problems can be problematic, but if you think them through and make a chart, they become much easier. It can help you to sort out the information in a problem. So I've created a chart here similar to what you might want to put on your paper. And here's a sample problem. A grocer wants to make a 10-pound mixture of cashews and peanuts that he can sell for $3.29 per pound. However, he doesn't want to sell them for less than it costs him to get them. So if cashews alone cost $5.60 per pound and peanuts cost $2.30 per pound, how many pounds of each must he mix? Now let's think about that. He wants to make a mixture. He's got some pretty expensive beans, these cashews, and some pretty cheap ones, these peanuts. And his price for the mixture is going to be in between those two amounts. So this makes sense so far. We know that he's going to have a certain amount of the expensive ones, a certain amount of the cheap ones to make it cost the same as the mixture. So I'm going to set up some variables. C is going to represent the pounds of cashews. I'm just using C so it helps me remember. And then there's a relationship between the amount of pounds of cashews and the amount of pounds of peanuts. I know that in all, I want 10 pounds. And if the cashews weigh C pounds, I have to subtract that from the total to get the weight of the peanuts in the mixture. That's where I came up with 10 minus C. It's probably the hardest part of the problem. Now, if the cashews cost $5.60 a pound, the total cost for whatever pounds I have is going to be $5.60 times the number of pounds, or 5.6C. If the peanuts cost 10, or the weight of them is 10 minus C, and they cost $2.30 per pound, I'll do the same thing. $2.30 is represented by 2.3, and I'm keeping the 10 minus C in parentheses because I want to multiply that price by the whole number of pounds, not just 10 and not just C. So I'm going to use those to write my equation. 5.6C plus 2.3 times 10 minus C is going to equal 32.9. Where did I get that number? Well, the cost of the whole mixture, 10 pounds, is going to cost $3.29 according to the problem. And so I know the cost is going to be $32.90 for the whole thing. Now I'm going to combine some like terms, 5.6C minus 2. First I forgot to do the distributive property. 2.3 times 10 is 23. 2.3 times C is 2.3C. Now I can combine like terms because I have no parentheses left. 5.6 minus 2.3 is 3.3C. My 23 comes down and my 32.9 comes down. Now I have a two-step equation where I can subtract 23 from each side. Leaves me with 3.3C unchanged, but that equals 9.9. Now I'm going to divide both sides by 3.3 because it's being multiplied, and I end up with 3. There are going to be 3 pounds of cashews. Now, if I'm not done there, I have to go back to my 10 minus 3, which is 10 minus C, and that represents 7 pounds of peanuts. Notice he's going to have more peanuts because they're cheaper in this combination. So to check it out, 5.6 or $5.60 times 3 pounds plus 2.3 or $2.30 times 7 pounds has to equal $32.90. Multiplying these out, I get 16.8 plus 16.1, and that really does equal 32.9, so it checks out. Finally, you've got some volume problems thrown into this unit, and you just need to remember these complex volume questions. A lot of times will include pi. Pi is just a constant that you can use like any other variable, treat it exactly the same way. Kylie wants to fill a cylinder vase 3/4 full before adding flowers. Her cylinder vase has a radius of 4 inches and a height of 10. What volume of water should Mary pour into the vase? Well, the formula for the volume of a cylinder is volume equals pi times radius squared times the height, and you have all that information. Volume equals pi times 4, I replaced the 4 for the radius, times 10, which I got from the height from the problem. Simplifying this, now notice I'm not using any approximation for pi here until I get to the very end, because we don't have a real value for pi, we only have approximations. So 4 squared is 16. If I multiply that by 10, I get 160 times pi. Here's where my approximation step can come in because there's no step left. 160 times 3.14 is about 502.64. And that's the volume. But you only want 3/4 of that. So you have to go back and do one more step, multiply 3/4 or 0.75 times 502.65. And that equals about 377 cubic inches. I hope that you got something out of this review. I know I went pretty quickly, but if you have questions on any of the concepts or skills that I showed here, you can go back and watch them again, of course, but I've got many more examples I could share with you. Just give me a call, send me a note, or drop into my online classroom, and I'll be glad to help you out. Good luck on the quiz.